Hello everyone, my name is Lila Ford. This is my Teach 1 for week 6, Time to Adverse Events, questions 5 and 6 for HAP 725, Statistical Process Improvement at George Mason University. Question 5 uses the data from the previous question and asks, what is the daily probability of referrals to each of the ultrasound, neurology, and combination of the two clinics? Okay, so these are some of the steps that are provided in the question. Step 1 would be to sort the data. Step 2 is to calculate the difference between the two consecutive visits. Step 3 is to find the average, which they provide as A. Step 4 is to find the daily probability, which would be 1 over A. And then examine if there has been a change by splitting the data into equal sets and calculating the probability for each half of the data. The difference would show the change in rates. So I chose to complete this question using Python. So the first thing I did was import libraries, pandas, numpy, and datetime. I then imported the data, specifically the sheets for neurology and ultrasound. And then I showed just the neurology data so we could see what it looks like. It has two columns, ID and neurology, which is dates. So here what I did is rename the columns for neurology, change that to referral date, and then I added another column that was the year. So you can see at the bottom here, it's the year and then the referral date. And then I did the same thing with the ultrasound data set. And lastly, I just dropped the ID column since we don't need that column anymore. Looking at the neurology data, I split it by year between 2016 and 2017. And here's the referral dates, just a few examples of them split by year. Same thing with the ultrasound data, same code, but just splitting that data into 2016 and 2017. So here I made another data frame that combined the neurology and ultrasound into one, and then I sorted it by the referral date, and I have some of it printed right there at the bottom. It's just, again, the referral date and the year. And then here, just like I did for the neurology and the ultrasound, I just split the combined table by year. So we have the 2016 data and then the 2017 data. Step is to find the days between the referrals. So for the neurology 2016 data, I made a new column called days between with the difference between the two. So you can see like the difference between 7/18 and 7/19 is 1 day. And then the next thing I did is convert that to a float so it can be used for calculations in the next steps. So for the calculations, the first thing I did was take a sum of the total number of days between. Then I did a count of the number of referrals to find the average, which was the total sum divided by the count. And the daily probability is 1 over the average. And you can see the results. The sum was 164, the count was 17, the average was 9.65, and the daily probability was 0.104. 17, I just did the same thing, but for the 2017 data for neurology. So I made a new column for days between and the difference between the two referrals. Then I changed that column to a float, found the sum, which in this case was 161, found the total count, which was 20. The average was again the sum over the count, which was 8.05. And then the daily probability is 1 over the average, which is 0.124. So then I just did the same thing again, but for ultrasound 2016, I made the column of days between. I found the sum, which was 182. The count was 41. The average, which is sum over count, is 4.44. And the daily probability, which is 1 over the average, is 0.225. So for ultrasound 2017, it's again the same thing. I made the days between column. The sum is 177. The count is 35. The average, which is the sum over the count, is 5.057. And the daily probability, 1 over the average, is 0.198. So then I did the same thing again, but for the combined column. So I did the days between, I did the sum, which was 182, the count was 59, the average, which was the sum over the count, was 3.08, and the daily probability, which is 1 over the average, was 0.324. Finally, I did the combined for 2017, which the sum for that one was 177, the count was 56, the average was 3.16, and the daily probability was 0.316. So the last step is to make the final table. I have the services, which are neurology, ultrasound, and neurology and ultrasound, and then I put the averages, the daily probability for both 2016 and 2017 all into one table. So here you can see that the daily probability for neurology increased, the daily probability for ultrasound decreased, and for neurology and ultrasound, it was a slight decrease. So for question 6, it's asking, in the past 3 years, there have been the following incidences of privacy violations. A disgruntled employee sold information on May 11th of year 1. Another disgruntled employee sold password to the system on December 12th of year 3. There were 4 instances of clinician discussing patient information in social gathering on December 5th, year 2, January 25th, year 3, May 27th, year 3, and September 1st, year 3. Days of incidences of other types of privacy violations were on May 11th, year 1, November 22nd, year 2, and December 27th, year 3. And it's asking which type of privacy violations are more frequent. So I chose Python for this question as well. I imported the libraries and the data. I put the data into an Excel sheet with the columns being the dates for each different kind of event. So then I just changed the dates into a format that would allow me to do calculations, and did an average day to next event, which would just be the difference between the two dates divided by the total number of differences. In this case, there's only 2 dates, so it was just the difference of date 2 minus date 1 divided by 1, which is 945. Information of discussing patient info in social gatherings. There were 4 different dates, so again, I just changed the format to allow them to do calculations. I subtracted the difference between the date 2 and date 1, plus the difference between date 3 and date 2, plus the difference between date 4 and date 3, divided by 3, and I got 90 for that calculation. And lastly, for the other category, again, just changing the dates into a format to do calculations. I subtracted the date 2 from date 1, and then date 3 minus date 2, added those together, divided by 2, and got 480. So from there, I was able to find the daily probability of the 3, and I just took 1 over the average. And you can see the daily probability for the employee selling information is 0.001. The daily probability for discussing information at social gatherings is 0.011. And then for the other category, the probability is 0.002. The thing I did is just put all the information together into a chart. So I have the event, the average, and the probability. So you can see the highest daily probability is patient information discussed in social gatherings.